Okay, I'm going to go over the test we took. And we have a case in number one where we're getting less and less and less. So we have a decrease. Now, on the first test, or on the sample test, we had an increase. So we were getting numbers like 1.08 something. And so we said it was 100% plus an 8% increase. Point 0.08 change to decimal. So we were taking one away from all the numbers and getting this, and then that decimal point 0.08 and changing that to percent, which was 8 point something percent. And so we had an increase in the 8% range. A lot of you on this test didn't take the one away on this, and it looks a little different on this. So when you have a decrease, we're going to still do exactly what we did before. The next one divided by the one before. So 1.14 divided by 1.23. And so we'd have to multiply this by 0.9268 to get this. 0.9268. I'm going to write that down there. But what percent decrease is this? Well, it's not 100% and it's not 92%. It's we got to take away 1. So we're going to subtract 1 and then times 100, and it's a 7.317%, a negative 7.317% decrease. So it's how far this is below 1. It's down below by 7%. Before it was above 1 by 8%. Now this is pretty easy. We can just drop in our head the 1 and we get the 8%. But when it's negative, we got to subtract the 1 from it so we can see it. Or we got to figure out this plus what makes 1 and plus 7.317. So I'm going to continue doing that down the line here. 1.05 divided by 1.14. So the number I'd have to multiply here is 9.9211. But if I subtract 1, I get and then times 100, I get a negative 7.9894895% decrease, down by 7%, 7.8%. 0.97 divided by 1.05. That's what I'm multiplying by. 0.9238 times this would give me this number, but the percent decrease is minus 1 times 100 to change it to percent, negative 7.619% decrease. 0.90 divided by 0.97. So I'm multiplying by 0.9278, which means I have a decrease of minus 1 times 100 of 7.216, negative 7.216%. So I want to take the average of these numbers for my first answer, the average percentage decrease. So they're all negative, so I'll just put negative in my answer. So I'm going to go 7.317 plus 7.895 plus 7.619 plus 7.216 divided by 4, and I get a 7.512% decrease. But my model is the amount after some time is the starting amount times 0, which was 1.23, times every time we're taking it times some number like this, or 1 plus this in decimal plus a negative 0.07512, which should be the average of these. And I could average these, or I could just do 1 minus 0.07512, 0.92488 to the t. So I got this times this to the t. Now to write this as a base E model, it's tempting to do going to straight to compounded continuously, which is not quite correct. That would be A of t equals A0 e to the percentage increase or decrease. This number, which would be negative in decimal, 0.07512 t. But that's changing the model from increasing annually to increasing continuously compounded. If we want to just go straight to the same model as this, we'd be A of t equals 1.23. We would just rewrite this decimal as a power of e. E to the ln 0.92488 times t. So now, this is a decay model, so I'm doing a half-life. So I want to know when either this is equal to 1/2 or this is equal to 1/2. I'm going to go with this one to start with, equals 0.92488 t. E, to the, not t, but to the t. Sorry, that's the power. So I want to know what I have to multiply, whatever the starting amount, doesn't matter what it is, to get half of it. So this number has to be 1/2 times whatever amount you have to get half as much. So I'm just looking for what makes this be a half. I have to solve for the power, and my power rule is if I have a base to a power a and it comes out to be c, that means log base b of c equals the a. This is how I solve for a power. I need to solve for a power, so I rewrite this. This is the base, so I have log subscripted for the base 0.92488 of this thing, c, what it's equal to, something to a power is equal to c, this is the c, of 1/2. Log of 0.5 with this base is t. Now if I used this model instead of this, I would have ln of, oh, no, I would have ln of, if I use this model, I would have 1/2 equals this e to the ln 0.92488 to the t. Now, this is base e, so I could write this in base e, which should be e to the ln 1/2 0.5, both the base e, so ln 0.5, I'll put 0.5, equals ln 0.92488, and this comes down times the t, times the ln. So I have to divide by this. And this should be the same. So I'm going to go to the calculator and check and make sure I'm getting the same. Now on the calculator, I go to math, go down to change a base, and I want to put in 0.92488 of 0.5, and I get t of 8.876. And this was in years. If I did this way, I have ln 0.5 divided by ln of the average of these, which is 0.92488. And you notice I get the same number. Okay. That's one. And this is one that a lot of people messed up this because they didn't realize it was how much different this is from 1. Just like on the sample test, how much is this number different from 1? It was 0.08 or 8%. This is negative 0.73. It's less than 1 by 7.3 or 0.073, and we do that. So you do this divided by that, get the decimal, subtract it from 1, and then make it a percent. Or subtract 1, subtract 1, and it comes out negative. So that's number 1, and it was 3 points for getting this right, 3 points for this, 3 points for this, 3 points for this, and 3 points for that. Number 2. So we have bases that are not alike, so you can change the base. 6, according to the rule, a can be written as log in any base you want to do, the base to the log base of a. So b to this power is a. So 6 is, and I can go into any base. I'll do it in base e first. 6 is e to the ln 6. That's another name for 6. To the x minus 3 equals. Another name for 14 is e to the ln 14. And that's to the x, and so the x comes down because it's when you got a power to power, you multiply. This is times e to the ln 8. That's an 8. That's a 14 to the x. And this is 6 to the x minus 3. Now, when you this has to come down times this. So I'm going to get ln of 6 times x. And then we're going to get ln 6 times the negative 3 minus 3 ln 6. And it would be e to this power equals, and it would be e to this power plus this power, because when you multiply, you add the powers. X ln 14 plus ln 8. And now, since they're both the same power, we can drop that. And we can, there's some x's here and some x's here. I'm going to subtract x ln 14 from both sides. So I have x times ln 6 minus ln 14. I'm subtracting them from both sides. And I'm going to add 3 ln 6 to both sides. So this equals ln 8 plus 3 ln 6. Then I have to divide by ln 6 minus ln 14. And I can type that into my calculator. A lot of reflection there, so I'm going to come over here. Put parentheses around my numerator. That's going to be ln 8 plus 3 ln 6. Close the numerator. Divided by, open the denominator. That's going to be ln 6 minus ln 14. Close the log, close the denominator, and I get negative 8.798. Now, if I were to go to base 10, this would be 10 to the log base 10 of 6 to the x minus 3. 14 would be 10 to the log 14 to the x times 10 to the log 8. That's 8. Now they're all in base 10. But I need to get these together, and when I multiply, I add the powers, and so I'm going to get, and here I have to multiply the powers, so I got log 6 times x minus 3 times log 6 equals, the power comes down, so I get x log 14. And when I'm multiplying, I add the powers. This is the power here and the power here. You notice it looks almost the same. Here it's log base 10, here's log base e. And it turns out if I do exactly what I did before, for instance, subtract x log 14 from both sides, and add 3 log 6 to both sides. These are gone. There's an x in both, so this is x times log 6 minus log 14 equals These are gone. I have over here log 8 plus 3 log 6. Then I divide by log of 6 minus log 14. And I can type this in my calculator and I'll get the same answer we had before. That's number 2. That one was worth 5 points. 3 points, 3 points, 3 points, 3 points, and 3 points. 15 and 5, 20 possible on the front page. Second page. We have a power rule. It says a log of a power. So if I have log in any base of a to a power, the power can come down and be times c log base b, still of a, but the power comes down times. Okay, so the square root of 2 comes down. Log, which is understood, base 10 of 10. To what power I take 10 to get 10? This is 1 times the square root of 2, which is square root of 2. Power comes down, so we get z log base 36 of 6. So what power do I take 36 to get 6? Well, I need to take the square root, and the square root power is 1/2. So this is 1/2 because 36 to the 1/2 means square root of 36, which is 6. So 36 to 1/2 is 6. So this is 1/2 times z. So the answer to this is z times 1/2. Often written the half first. Here we got e to log base e, and when we have e to a base and a log of the same base, they cancel out, and we just get 5 pi. Okay, next one. When you have the log in the same bases of two things added, you add the powers when there's a multiplication problem. So log base 2, this is going to be of 3x plus 2 times x. And now we have changed a log to a power. Log base b of a equals c changes to base b to the c power equals a. If I'm down to a single log equation, I'm going to go the base to the c power equals what's inside the log, the argument. So I got x times 3x, which is 3x squared, and x times a plus 2, which is plus 2x. 3 squared is 8. So I'm going to subtract 8 from both sides because I have a quadratic. And that factors, or you can graph it and find the x-intercepts that make it equal to 0, but 3x and x multiply to be 3x squared. And we want to get 2, and if I do 4 here, say, and 2 here, 4 times 2 is 8. If I get, and I want a negative, so one of these has to be negative. This would be plus, this is 6x, this is 4x. I want plus 2, so I go plus 6x minus 4x is the way I factors. Then I set the factors equal to 0. Add 4 to both sides. And divide by 3. Or I set this factor equal to 0. Subtract 2 from both sides. And so x is either that or that. But putting in a minus 2 would be a log of a negative. This might not be, but that is for sure. And 4/3 is positive in both of these. So can't use this answer because you can't do the log of a negative. But you can find the log of 4/3, so this is the answer. All right, next one. So now we're subtracting. Still log 7, so when you subtract, you divide. So we get log base 7 of 26 minus x over x minus 1 equals 2. And log to power equation conversion. The base is 7. This is the power. The base is 7. This is the power equals this. Seven squared is 49. And a lot of people got these backward. They said 2 to the 7th. No, it's 7 to the 2. Equals 26 minus x over x minus 1. Now if I want to solve for x, I'm going to multiply by x minus 1. And these cancel. This is 49x minus 49. Want all the x's on the same side, so I go plus x plus 49 plus 49, and I get 50. X equals 26 and 49 is 75. Divide by 50 on both sides to find x. And 25 goes in there 3, 25 goes in there 2. And I want to make sure that that doesn't cause any negatives. 26 minus 1.5, it's okay. 1.5 minus 1 is still positive, so we can use it. All right, let's do this one now. Here's the model. And we got to find K when T is 6 days. A0 is 4 grams, and what's left after 4 days is that. So we got 1.3389 equals 4.000 e to the k, which we want to find out. T is 6. So I divide by 4. So that I'm down to just on a power equation, k times 6 or 6k equals 1.3389. 1.3389 divided by 4 is 0.3347. Now I'm going to go use rule number 1. So I'm going to go to logs. Whenever you need to solve for power, you go to logs. So log of some base, we'll see my base is E, so I could have written ln, of, in the rule, this is, if I got log base B of A equals C, is B to the C equals A. So the base is E, base, to the power that's on the other side. So this power, I'm going the other way. So I'm going from this equation, C goes to what I'm equal. I'm solving for the power. So equals 6K, and the A is in here. What's in here is what the B to the power is. So I have this. Well, log base B is, base E is just ln, and A was what this was equal to, so that goes here, 0.3347. So I got log base E, or ln of this. ln of 0.3347, that's log base E of this, equals 6K. So divide by 6. So I've got natural log of 0.3347, close parenthesis, natural log of this divided by 6. And K turns out to be negative 0.1824. So if you started with 20, so starting amount goes there, to the K, well, K we just figured out to be this for radon, times T, which is 20 days, oh, 10 days, 10 days. Knew there wasn't two 20s. Started with 20 grams, E to the K times the number of days, 10 days. And that'll give me the amount after 10 days. And so I just got to type this into my calculator. 20 E to the negative 0.1824 times 10. Times 10. And I get 3.2276, and I'm finding how much is still radioactive, and this would be in grams. Now I want to find out, how long does it take to go to half? Well, if I'm starting with any amount, doesn't matter. If I want to have half as much left, I have to take the starting amount times a half. So E to the KT has to be a half to know the half-life. E to the K, which we know is negative 0.1824, times T has to be 1/2. If this were to equal a half, half times any starting amount gives us half left, which is what a half-life is. Half times the starting amount is half-life, makes it what's left. So I'm going to solve this. And once again, now I'm trying to solve for a power, so I use the conversion equation. So the power comes down, the base is the base. So the base here is E, so log base E, which is ln of 1/2 equals the power, because that's what we're solving for, which is negative 0.1824 t. So we're going to have to divide by negative 0.1824, negative 0.1824. So we're going to go negative 0.1824 divided into the ln of 1/2, and that should be the half-life, which is approximately, and these are real numbers for the real isotopes here, ln 0.5 divided by negative 0.1824. Oh, what did I put here? Forgot to put divided. Second insert divided by negative 1.8.24. Oh, what did I type in wrong? Oh, I got a parenthesis on the end that I don't need. And now what's wrong? Didn't I hit delete? There we go. And I get half-life being 3.8001-ish days. Okay? That's how long it would take for it to be half gone. All right, final question. So we're going to be compounding quarterly, so that means ends are 4 for quarterly. So the amount after some time is the starting amount. A0 is the starting amount, the amount at time 0, equal parenthesis 1 plus the interest rate in decimal, and so that in decimal is 0.0425 over how many times you're going to get the money. You're going to get it once each quarter, which is 4 times. They're going to add your interest, and they're going to have to do that 4 times in a year times the number of years. So the T is the 9, the interest rate is, the rate is 1 plus the interest rate 0.0425 divided by 4 to the 4t power. And so this is just type it in the calculator. 8,000 parenthesis 1 plus 0.0425 divided by 4 times a year. So we got to take the interest rate, do only 1/4 of it, but we're going to do it to the power of 4, which means we're going to do that 4 times for each year, times the number of years we're going for, which is 9, and I get, there'd be $11,703.92. So how long would it take to grow to 10,000? So 10,000 is what we ending amount wanted to be, still starting with 8,000. 1 plus the interest rate, but we're compounding monthly, so now we got to do the interest rate. It's still 4.25%, or in decimal 0.0425. We're going to do it not 4 times a year, quarterly, but monthly, so 12. We multiply by this, we'll get it after 1 month, but we're going to have to do it times this 12 times to get through the years, through 1 year, and then t for how many years. So I got to solve this. So I want to get it down to a single power equation without the 8,000, so I'm going to divide by 8,000. And 10,000 divided by 8,000 is 1.25. This is 1 equals 1 plus 0.0425 divided by 12 to the power 12t. I'm trying to solve for a power, so I've got to go to a log. And the conversion of a power equation to a log equation is same base for the log as the original power equation, which is this, 1 plus 0.0425 divided by 12. That's the base of this equals 12t. The power, base, and c. So now I can get the log of this and then divide by 12. To do the log of this, I can rewrite, change a base rule, log of this divided by the log of this. So I'm going to do that. Log of 1.25, close parenthesis, divided by, or use the change of base and type in the base, this expression, but I'm going to type in just log of 1 plus 0.0425 divided by 12. So log of the base, log of the argument, log of the base, equals 12t. So that equals 12t. So I divide both sides by 12, which means I'm going to take this and divide it by 12. And I get t to be 5.2597, which would be 6 years. To go from 8,000 to 10,000. Now I could do the whole thing again with, they want to know how long it takes to double, so I could start with 8,000 and 16,000 here. But when I divide by 8,000, I get 16,000 divided by 8,000, which is just 2, has to be this. 1 plus 0.0425, but now I'm not compounding monthly, I'm compounding daily, so that's going to be divided by a little bit different number. And we have to take it to the power not 12 times a year, but 365 times a year times the number of years. Okay. So again, I'm solving for a power, so I need the log. The log, this is the base. Divided by 365, that's the base. So log base this of the number 2 equals the power. So I'm going to figure this out, and I can either type it in with the base. Let's do this, and I did up here I did log of this divided by the log of this to get this number. Let's do the change the base rule here in the calculator. So I'm going to go math, come down to the log in any base, and it allows me to type in the base, and my base is complex here, so I'm going to go parenthesis 1 plus 0.0425 divided by 365, close parenthesis. So there's the base of the log, and I'm doing it of 2, and I'm going to get that number, 5953.26 equals 365t. So I'm going to divide by 365, and I get t is equal to 16.31. This is the time, and we're doing it in years. The time is in years. So it'll take 16.31 years to double the amount of money. And this just says how much will be in the account after 9 years if you start with 8,000. Compounded continuously, that's e to the interest rate in decimal. The interest rate was 4.25. In decimal, it is 0.0425. You notice that we're not doing 100% plus 4% more. We just do the rate of increase to the t times t, which is 9. So this is just type it into the calculator. 8,000 e to the 0.0425 times 9 years, and we get $11,727.56.